Hey guys, welcome to ANS Solver. Today we'll be learning the concept of properties of logarithm and natural log, okay, which is a subtopic in the chapter of logarithm. So in this video, what we'll do is we'll go over the concept, okay, there are many properties which you need to remember, and then we'll do, too many past paper examples and other type of questions so that you have a strong grip on this chapter. So the first thing is let's start with the basic of logs. Okay, when do we use logs? Let's say if I have something like 2 raised to x equals to 16. And let's say if I need to find x here. So how do I find x? I write this as x equals to the log of 16 with the base of 2. Okay, the 2 here will be at the base. Correct? So you can even solve this on the calci. So if you see on the calci, you'll have a button something like this. Correct? So in the base you put 2 and in the top you can put 16. And when you solve it, you get your answer basically as 4. So the value of x is 4. Correct? This is the basic use of logarithm. Okay? But now there are some properties. Okay, there are some properties which you need to remember. They are very important properties. And logarithm is a chapter like, they'll ask you an individual question on it. But even other topics like differentiation, integration, and other chapters in P3 will also need, logarithm all the time. So you need to remember these properties, okay, properly so that you are able to use them. Okay, so the first property is basically log A plus log B is equal to log of A into B. So an example is basically log of 5 plus the log of 7 will be equal to the log of 5 multiplied by 7, correct, which is simply equal to the log of 35. Correct? This is the basic use of the log property. Correct? Then I have the second log property, which is log A minus log B, which is basically equal to log A over B. Correct? So what I can do is, I'll give you another example where I have log 100 minus log 10, which is equal to log of 100 over 10. Correct? Which is basically equal to the log of 10. Correct? This is the property I have. Okay. Another thing you need to know is, I write this in the third property. Okay, so there are two properties here, many properties. The first property here is that log of any number, let's say log A, and let's say if the base is not specified here. Okay, if the base is not specified, we assume the base as, okay, 10. Correct? If let's say I have something like, for example, I have log 5. Okay, we assume that the base here is 10. Okay, if it's not specified. If in cases it's specified, then we use that number. But if it's not, we take it as 10. Okay, and the second property here, okay, which is a mini property, is basically, let's say if I have something like log A with the base A, okay, it's basically equal to 1. Okay, this is what you basically need to know, a very, very important property. So let's say I have something like log of 5, okay, with the base 5, it will be equal to 1. Or let's say if I have something like only log 10, even this will be equal to 1, correct? Because as the base here is not specified, we take the base as 10, and as the constant and base are equal, we get 1 simply. Correct? This is what we get. Now what we can do is we can go to the fourth property. Correct? The fourth property is basically that the log of b with the base a equals to c, okay, can be written as b equals to a raised to c. Correct? This is how I can write this. So let's say I have something like log of x with the base 2, which is equal to 8. Correct? And they'll ask you find x. Correct? This is what you'll get. So that's simply x equals to 2 raised to 8. Correct? Clear with this log property? Okay. Now we can go to the fifth property. Okay. So this basically means that log of a raised to b, okay, will be equal to b log a. Okay, here the base is nothing, that means it's 10. Okay, a is on top and it's raised to b. So an example can be something like log of 5 raised to 10 can be written as 10 log 5. Or let's say log of 7 with the base 2, okay, raised to, let's say 3 here, okay, log of 7 raised to 3 with the base 2 can be written as 3 log 7 with the 2 here. Correct? This is what I'll basically get. Okay. Now we can go to the sixth property. So the sixth property is basic. It's basically log of a with the base b will be equal to log of a divided by log of b. Basic property. Let's say I have log of 5 with the base 7. It can be written as log of 5 divided by the log of 7. Got it? Now the seventh property. Okay. Let's say if I have log 1. Okay. The base here can be anything. Okay. Any number. It doesn't matter. Okay. Let's say you take any number. If it's 10, it can be 10. If it's 5, any number you take. But if you have something like log 1, it's always 0. Basically, let's say I have log of 1 with the base 5, it's 0. If I have only log 1, that means if the base is not specified, it's 10. Then also I have 0. If I have, let's say, log 1 with the base 2, it's 0 again. Because when there's the 1, the answer is basically 0. Okay, got it? Now, the eighth property, okay, is basically a raised to log m with the base a will be equal to m. A very important log property. Let's say I have something like 5 raised to log of 10 with the base of 5. This will be equal to 10. Basically, you can say this 5, 5 and the log gets cancelled out. And you only get 10. Correct? Or let's say if I have 2 raised to the log of 8, okay, with the base 2, this will be equal to 8. Correct? This is what I'll get. Now I have property number 9. Okay, a very important property. Let's say I have log of a raised to m, okay, on top, and in the base I have b raised to n. I can write this as, this is on top and this is the base. I can write this as m over n with log a with the base b. Correct? So the example here is basically if I have something like log of 5 raised to 7 and in the base let's say I have 2 raised to 3. Correct? I can simply just write this as 7 over 3 with log of 5 with the base 2. Correct? Simple property. Okay, I can give you another example. Let's say I have something like log of 5 raised to 2 with the base of 5 raised to 3. I can write this as 2 over 3 because the 2 here in the numerator, 3 here in the denominator. Okay, and I'll have log of 5 with the base 5. If both the base and the top are equal, it's basically equal to 1. So I can write this as 2 over 3 multiplied by 1. So I can simply get 2 over 3. Correct? This is an example. Okay. Now I can do the last property, the 10th property. So this is a very rare property. It's not used much or asked much, but just remember it so that you're on the safe side. Let's have a raised to log of c with the base b. Okay. It will be equal to c raised to log of a with the base b. Okay. So it's a very it's a rare property. It's not asked much, but if you want to remember it, you can remember it. So an example can be 2 raised to log of 5 raised to 2. Okay, sorry, 5 with the base 2. Okay, this can be equal to 5 raised to log of 2 with the base 2, which is basically 5 raised to 1. Okay, so it's a very rare log property. Okay, but yeah, if you want to use it, you can use it. It's up to you, but it's not asked much. Okay, so yeah, so these are basically the log properties which you need to remember for now. Got it? So yeah, so now we can go to the next concept, which is exponents or the natural log. I'll write this as natural log. Okay, if you have understood these properties, okay, the 10 properties which I've written, the natural log is same. The only difference, okay, in a natural log is that it's portrayed by ln. Okay, let's say if I have something like ln 5, it's basically log of 5, but the base is e. Okay, that's the only difference between a log and a natural log. Okay, and the ln, okay, uses all the properties, okay, listed above. Okay, this is what I can simply state. Correct? But now see, with logs, the thing is, once you know the properties, okay, you need to know how to use them. So we'll do a lot of past paper examples and many questions now, so that you're sure with all the properties and how to use them. Okay, so before we start with that, let's go over the properties all over again so that we are sure. So the first property was log of a plus b, sorry, log of a plus log of b will be equal to log ab. Correct? Then I have log of a minus log b, which is log a over b. Correct? Then 3, 1 will be log of a, and let's say if the base is not specified, then we take the base as 10. Okay, then I have log of a with the base a, where I'll simply get 1. Correct? Then I have log of b with the base a. Okay, if it's equal to c, then I can write this as b equals to a raised to c. Then let's say I have log of a raised to b equals to b log a. Correct? That's the fifth property. The sixth property is log of a with the base b can be written as log of a over log of b, and log of 1 with any number in the base will always be equal to 0. Then I have a raised to log of m with the base a will be m. Correct? Then the ninth property, the important one, where I have log of a raised to m on the top with the base b raised to n. This can be written as m over n log of a with the base b. And the 10th property, a very rare property, but just remember it. It's basically a log c with the base b is equal to c log b with the base a. Sorry, c raised to log a with the base b. Sorry, my bad. Correct? So these are the 10 properties which I have. And yeah, the natural log is basically with the base of e. Correct? So these are the concepts. So now let's dive into the past paper examples and understand how to use these properties. Correct? So the first example we have is basically from 2017, Feb March paper 22. Okay, so I'll write the question down so that we are 100% sure. So I have 2 ln 2x minus ln x plus 3, okay, which is equal to ln 3x plus 5. And we need to solve this equation and get the value for x. Correct? So the first property which I can use here is that b log a is equal to log a raised to b. Correct? So I can simply write this as ln 2x raised to 2. Correct? Here I can use this property minus I can write this as ln x plus 3 equals to ln 3x plus 5. Now what I can do is I can write this as ln, I can write this as 4x square when I take the square inside, so I do 2 square into x square, correct, minus ln x plus 3, correct, which is equal to ln 3x plus 5. Now the log property which I can use is that log of a minus log of b is equal to the log of a over b. Correct? Whether it's log, whether it's ln, is the same thing as ln is a natural log. So you can use this property. So I can write this as ln, okay, 4x square divided by x plus 3, correct, which is equal to ln 3x plus 5. Now when you have ln on both sides, the simple way to remember it, you can simply cancel both ln's, or you can simply write this as e raised to 4x square over x plus 3, correct, will be equal to e raised to 3x plus 5. Okay? Or if you want to remember this is a tougher way. You can just simply write this as, you can cancel ln on both sides and simply just write this as 4x square over x plus 3, which is equal to 3x plus 5. Correct? This is very simple. If you have ln on both sides, you can just cancel it like this. Okay? And now you can start solving for x. So I get 4x square, which is equal to 3x plus 5, which is multiplied to x plus 3. So I can write this as 4x square equals to 3x into x plus 3 plus 5 into x plus 3. Correct? So I can write this as 4x square equals to, when I take 3x inside the bracket, I get 3x square, correct, plus 9x, because 3x into 3 is 9x, plus 5x plus 15. Correct? Now I can get everything to one side. So before that I can write this as 4x square equals to 3x square plus 14x plus 15. Correct? This is how I can simply write it. Now I can get everything simply on one side. So I get 4x square minus 3x square minus 14x minus 15, which is equal to 0. So I can write this simply as x square minus 14x minus 15, which is equal to 0. Correct? So now what I can simply do is I can solve this quadratic on the calci. Correct? I can simply solve this on the calci. Okay, so for that I can go to mode. Then I can click on 5 where equation is written. Correct? Once I click on 5, I can click on 3. Correct? When I click on 3, I basically get 3 coefficient boxes. Correct? I can simply click on 3 coefficient boxes. In the first box, I can put 1, which is the coefficient of x square. Then I can put minus 14, which is the coefficient of x. And in the last one, I can put minus 15. So when I put 1, minus 14 and minus 15 and click on equal to, okay, I basically get two values of x. First, I get my x here as 15 and I get my x as minus 1. Now, which value of x should I choose? Before that, two more important things you need to remember here is that log, okay, of a negative is not possible. Okay, this is a very important property to know. Log of any negative number, like if you do it on the calci, let's say you do log of negative 5, you'll get a math error. Correct? Or log of 0 is also not possible. You'll get a math error. Correct? So what you can do first is, let me take the value of 15, which I have. See 15 here, place it in the value of x. If you are getting ln of a negative value, okay, that means you can't use 15. But if you see here, if I put, x as 15 here, I'll get 2 into 15, which is 30, which gives me a positive value. If I put 15 here, I'll get 15 plus 3. Correct? 15 plus 3 is 18, which will give me a positive value. So ln of positive is okay. And when I put 15 here also, I get 3 into 15 plus 5, which is a positive value. And ln of a positive value is possible. So I know that 15 here, okay, is a confirmed answer for sure. Now, when I take minus 1, okay, when I put minus 1 here, I'll basically get 2 ln of 2 into minus 1, which is negative 2. And ln or log of a negative number is not possible. Correct? This is basically not possible. That means this value of x being equal to negative 1 is eliminated. Okay? So the only value which you have is basically x equals to 15. Correct? So you basically need to know how to verify like this. Okay, this is how they can, test you on small log properties. Correct? You will basically get two values. You might need to eliminate one. Okay, because you're getting log of a negative number, which is not possible. Correct? Or in some cases, you can get two values of x and both of them are satisfying the equation. Okay, if both are giving positive, then it's okay. But if there's something negative, like here we got ln of negative, then you need to eliminate that value of x. So the only value of x is basically 15. So this was one type of question. If you didn't get it, it's alright. Okay, because it's a complex chapter, you need to know how to use the properties. We'll go to the next past paper example. Okay, so this is basically from 2021, March paper 32. Okay, so here I need to solve the equation ln x cube minus 3, which is equal to 3 ln x minus ln 3. Okay, and I need to give my answers to three significant figures. So I'll write the question down first. So I have ln of x cube minus 3, which is equal to 3 ln x minus ln 3. Correct? So the first log property which I can use is that b log a is equal to log a raised to b. Correct? So I can write this as ln x cube minus 3, which is equal to ln x cube, correct? Because I can use this property here, correct? Minus ln 3. Then I can use the log property, which states that log of a minus log of b will be equal to log a over b. It's log or ln, it doesn't matter. Ln is a natural log, it's completely alright. So here I'll basically get ln x cube minus 3, which is equal to ln x cube over 3. Correct? Now I can simply cancel ln on both sides and write this as x cube minus 3, which is equal to x cube over 3. So I can write this as 3 into x cube minus 3, which is equal to x cube. Correct? Then I can write this as 3x cube minus 3 into 3, which is 9, equals to x cube. So here I can write this as 3x cube minus x cube, which is equal to 9. So here I basically get 2x cube, which is equal to 9. So I get my x cube basically as 9 over 2 here. Correct? So I get my x basically as the cube root of 9 over 2. Correct? This is what I simply get. So I can solve this on the calci. First I can do the cube root of 9 over 2 directly. So I get my answer here basically as 1.65. Okay, always see, you need to write this with 3 significant figures. So 1.65 is written to 3 significant figures. So this is basically the answer of your question. Got it? So in logs, basically when they ask you questions like these, you need to use log properties till the first 3 or 4 steps. After that, it's simple algebra to get your final answer. Correct? But you need to remember all your properties to implement them. Got it? Now let's do another past paper example so that you have a perfect grip. So this had come basically in 2020, October-November, paper 31. Okay? So you basically need to solve the equation where you have log 2x plus 1 with the base 10, which is equal to 2 log x plus 1 with the base 10 minus 1. Okay? You can simply just write this as log of 2x plus 1, which is equal to 2 log x plus 1, correct, minus 1. You can write it like this because, if the base is not specified, it's taken as 0. Sorry, it's taken as 10. My bad. So now, the first log property you can use here is that b log a is equal to log a raised to b, which we've been using here also. Correct? So I can simply write this as log of 2x plus 1, which is equal to the log of x plus 1 the whole raised to 2, because here I can use this property minus 1. Correct? This is what I can simply do. Then I can write this as log of 2x plus 1, which is equal to, as you can notice here, there's algebra. This is basically a plus b the whole square, which is equal to a square plus b square plus 2ab. Correct? So I can simply write this as log of x square plus 1 square plus 2 into x into 1, which is basically 2x minus 1. Correct? This is how I can write it. Now what I can do is I can write this as log of 2x plus 1 minus the log of x square plus 2x plus 1, which is equal to negative 1. Correct? now I can use the log property, which states that log of A minus log of B is equal to log of A over B. Correct? So I can simply write this as log of 2x plus 1, which is simply divided by x square plus 2x plus 1, which is equal to minus 1 here. Correct? This is what I basically have. Now I can use the log property, okay, which states that log of b with the base a equals to c can be written as b equals to a raised to c. Correct? Here I know that my base is 10. Correct? So I can write this as 2x plus 1 over x square, correct, plus 2x plus 1, which is equal to 10 raised to minus 1. So I can write this as 2x plus 1, which is equal to 10 raised to minus 1 can be written as 1 over 10 multiplied by x square is 2x plus 1. So I can write this as 2x plus 1, which is equal to x square over 10 plus 2x over 10, which is x over 5 plus 1 over 10. Correct? So now what I can do is I can write this as x square over 10 plus x over 5 minus 2x plus 1 over 10 minus 1, which is equal to 0. So I can write this as x square over 10. Okay, I can do 1 over 5 minus 2, which is basically gives me minus 9 over 5 x, and I can do 1 over 10 minus 1, which is basically minus 9 over 10, which is equal to 0. Correct? So what I can simply do is, as you can see, this is a quadratic, so I can solve this on the Calc. Correct? So what I can do is I can go to mode. When I go to mode, I can go to 5 where equation is written, then I can click on 3. When I do that, I get 3 coefficient boxes. Correct? This is what I simply get. So in the first box, I can put the coefficient of x square, which is 1 over 10. In the second one, I can put the coefficient of x, which is minus 9 over 5. And in the last one, I can put the constant, which is minus 9 over 10. So I get 1 divided by 10, which is equal to minus 9, okay, divided by 5, which is equal to minus 9 divided by 10. When I do that and I click on equal to, I get my x basically as 9 plus 3 root 10, which is a positive value. Okay, and I get my x basically as 9 minus 3 root 10. We've again got two values of x here. Correct? So now let's see if both values are fine. Okay, I know when I put the positive value here of x, okay, which is this one, 9 plus 3 root 10, which in decimal is 18.4. Okay, I'll get positive actually everywhere. Here also I'll get positive. I'll get positive in both the places. So I'm getting a log of positive. So I know that x will basically be equal to, because I need to give my answer to 3 decimal places, I can write this as 18.487. So I know this answer here is confirmed. Now let's take this value of x, okay, which in decimal is minus 0.486. So I know when I put minus 0.486 or 487 actually to be precise, okay, when I put minus 0.487, okay, multiplied by 2, I get minus 0.974. But then when I add 1 to it, basically, I get the log of 0.026 here. Correct? Which is basically log of a positive value. So it's perfectly alright even when you substitute this value in the equation. You don't get a negative answer. You never get log of a negative number. You get a positive value. So you can simply just write this as x equals to 9 minus 3 root 10 is basically minus 0.487 to 3 decimal places. So as you can see, your both the values which you have are satisfying the equation. So I just gave the sum because in the first question, here when we got a negative value, we straight away eliminated it because we got a log of negative, which is not possible. But here, in this example, when we got x as negative, even after that, when we substituted it in the equation, we never got a log of a negative number. We never got this. Correct? That means it's perfectly alright. And both these values are my final answer to 3 decimal places. Correct? Now, what I've done is, there are some other type of questions, very important type of questions, which they normally ask. So, I wanted to mention those to you because it's really important for you to understand these. So let's say if I get something like e raised to x multiplied by 2 e raised to x minus 1 equals to 10. And they ask you, to find the value of x. Correct? So how do you solve something like this? First, take e raised to x inside the bracket. So you get 2 e raised to 2x. Or for better understanding, when I take it inside the bracket, I get 2 into e raised to x the whole square minus e raised to x equals to 10. So I can write this as 2 into e raised to x the whole square, which is can be also written as 2 e raised to 2x minus e raised to x minus 10, which is equal to 0. Now what I can say is, let e raised to x be a. So I can write this as 2a square minus a minus 10, which is equal to 0. Correct? As you can see, this is a quadratic. So you might be knowing the steps on the calci as I've mentioned it above also, but I'll mention it again. So on the calci, you can go to mode, then you can go to 5 where equation is written, and then you can go to 3. Correct? So when you do that, you basically get 3 coefficient boxes. Correct? You get 3 coefficient boxes. In the first box, put the coefficient of a square, which is 2. In the second box, put the coefficient of a, which is minus 1. And in the last box, put the constant, which is minus 10. So when you put 2, minus 1 and minus 10, and you click on equal to, you get your x basically as 5 over 2, and you get your x basically as minus 2. But here in this case you don't have x, you have a, my bad. Correct? So this is what you get. Now I know I need the x, which is here, and I know e raised to x is equal to a. So I can write this as e raised to x equals to 5 over 2 and e raised to x equals to negative 2. Now, how do I solve something like this? So I can tell you a small trick here. Whenever you see e, always ln both sides. Ln because obviously in ln the base is e. So write this as ln e raised to x equals to ln 5 over 2 first. Because these are two possibilities. So first, let's investigate the first property. Correct? The possibility, sorry. Now I can use the property which states that log of a raised to b equals to b log a. Correct? So using this property, I can write this as x ln e equals to, okay, I can simply do ln 5 over 2. Correct? Ln e is 1 because e and e, even the base is e. So it's basically 1. So I get my x, which is basically equal to ln 5 over 2. Correct? So when I do ln 5 over 2 on the calci, I get my answer as 0.916. Correct? Now the other possibility which we have here, okay, we again do ln on both sides. So I get ln e raised to x equals to ln of -2. But here I have mentioned the property that a log or ln of a negative number is never possible. That means this possibility of getting x is eliminated, and the only answer I get is 0.916. Okay, so this was a type of question, okay, which they ask. Okay, so you need to know that when you get something e raised to x equals to 5 over 2, that time you need to, ln both sides, so that, here you can basically get ln e, which is 1, and get the final answer of the variable which you need. Okay, so I wanted to mention this type, but yeah, obviously you'll need to practice a lot to master this, to perfect this, to know when to ln or log both the sides. Correct? Now let's do another type of question, the last type. Okay, so here they have basically used indices. Okay, so basically I have 2 raised to x plus 2. So you need to know the indices property that if you have a raised to b plus c, you can write this as a raised to b multiplied by a raised to c. Correct? So I can simply just write this as 2 raised to x multiplied by 2 raised to 2, which is equal to 2 raised to x plus 10. Correct? Now 2 raised to 2 is 4, so I can write this as 4 into 2 raised to x equals to 2 raised to x plus 10. So I can write this as 4 into 2 raised to x minus 2 raised to x, which is equal to 10. As these are variables here, I can just write this as 3 into 2 raised to x, which is equal to 10. So I can write this as 2 raised to x equals to 10 over 3. Now I need x. Correct? So now when we normally have e here, we do ln, because even there the base is e. But here when we have a constant and we have to calculate something like this, we log both the sides because there's a constant and not e. So I basically get log of 2 raised to x equals to log of 10 over 3. Correct? So now I can use the log property, which states that log of a raised to b can be written as b log a. So I can simply write this as x log 2, which is equal to log of 10 over 3, which I can simply write this as x equals to the log of 10 over 3 divided by the log of 2, which now I can simply solve on the calci. So when I do the log of 10 over 3, correct, divided by the log of 2, correct, I can simply solve this on the calci and get my answer as 1.74 to 3 significant figures. Correct? So this is basically the final answer for x. Okay, so with this we come to the end of the concept of the properties of log. Okay, so as you can see in this video, we have discussed all the properties. We've discussed what a natural log is. We have solved a lot of examples so that we are perfect with the concept. But yeah, you still need to complete this chapter. So please view the next video, okay, to complete this chapter. Thank you very much.